Kia ora and welcome to video 5 of Agile Algebra. Let's crack straight into the problem. We've got a pretty messy expression here involving x to the 4, y to the 4, and z to the 4 terms, and we're needing to factorize it. We're first showing that x minus y plus z is a factor, because that is a big clue for the overall factorization of this expression. There might be different ways of doing this problem. In fact, we looked for a couple in the solutions, but there is definitely an easier way if you can see the connection between the x minus y plus z factor and the rest of the expression. All the best. Okay, so the first thing we need to do to factorize this expression, the hint is to show that this x minus y plus z is a factor. So we're using the factor theorem. For example, if we were trying to prove that x minus 2 was a factor of something, then x equals 2 would be a solution, and we would substitute 2 into the expression, and out would come 0. So what we're going to do for x minus y plus z is we're going to replace all the x's with x equals y minus z. So if we substitute y minus z into the expression above, wherever there's an x, the result should be 0. So we'll do that. We'll replace the x there, we'll replace the x there, and we'll replace the x there. It's a bit tedious, but it's a first step. So we do y minus z, all to the power of 4. Leave some space because that's going to need the binomial theorem to expand. We've got minus... I'm going to group the stuff together with the x squareds so I do less work. So we've got minus 2x squared, and x squared of course is y minus z all squared, and then I've got that multiplied by y squared and by z squared. Okay, so an explanation as to what I've just done there, if you didn't quite spot it. I've grouped that term there and that term together with a common factor of minus 2x squared, and then I've replaced that x squared part with y minus z. And then we've got a last term that we haven't touched yet, which is minus 2y squared z squared. Okay, from there we can expand out using the binomial theorem. So we've got y to the 4 plus... actually, it's not going to be a plus for the first term. The coefficients for the expansion are 1, 4, 6, 4, and 1. Y to the 4 is the first term. The next term is going to have 3 y's and a z in it, but the z's got a minus in the front of it, so I keep putting a plus there, and I shouldn't be. It's minus 4y cubed z. Then it's a plus because the next term we're going to take 2 y's and 2 z's. So it's going to be y squared, and it's minus z, and another minus z, so hence why it's a plus. Last, oopsies, that one's going to be a negative because of odd number. We're going to have a y there and z cubed, and then the last one plus. We don't need the 1, z to the 4. If you're not sure about binomial theorem because you've never learnt it, or it's a bit dusty for you, then Google it. There's plenty of resources to help you expand binomials. Okay, we've got y to the 4 plus z to the 4. Then we need to go minus 2 and expand this y minus z all squared. Y squared minus 2yz plus z squared multiplied by y squared plus z squared. And rather than expand it out, let's just see if we get cancellation. Okay, if we look at the y to the 4 terms, we've got a y to the 4 there, a y to the 4 term there, and a y to the 4 term there taken away, multiplied by minus 2, so those two terms all cancel. Then we've got a z to the 4 term there, a z to the 4 term there, and a z to the 4 term there with a minus 2 in front of it, so those terms cancel. So it's just saving us a little bit of work here. Just so that we can actually follow this, I will continue with the rest of the expressions to show that like terms will cancel each other out. Okay, the other things we haven't expanded in this bracket here are y squared times z squared with a minus 2. We haven't expanded minus 2yz times y squared, so that's going to be plus 4 because of the minus 2 in the front of the brackets, y cubed z. We haven't expanded this term, minus 2yz cubed with another minus 2, 4yz cubed. And then the last term we haven't considered is the z squared, y squared term. So minus 2 z squared, y squared. And then minus 2 y squared, z squared. Okay, let's see if we've got other stuff cancelling. Minus 4y cubed z plus 4y cubed z. Okay, that's good. Minus 4yz cubed plus 4yz cubed. And then the last one's y squared z squared, 6y squared z squared, minus 2 of them, minus 2 of them, minus 2 of them. So everything cancels, equals 0, therefore x minus y plus z is a factor. Now, how do we use that information to factorize this absolute beast of an equation? Sorry, an expression. We're factorizing an expression. So one way you could do it is to go, right, cool, I've got this factor, and let's have a ginormous factor here that we've got to try work out. I'll tell you the easy parts. It starts with an x cubed, because of course we need an x to the 4. We also need a y to the 4 in there, so there's probably going to be a minus y cubed in there somewhere. And we need a z to the 4, so it's probably going to have a z cubed in there somewhere. And then we go, and I tried this in a previous recording of this video actually, and I got to 10 minutes and I was still trying to expand brackets. So if you want to take a standard approach to factorizing without using the hint, there is a YouTube video. I'll link it below in the comments if I'm able to do that, and it's a pretty genius way of looking at it. But the first thing that the YouTuber does is go x to the 4 minus 2x squared y squared plus z squared, and then completes the square on the rest of the terms. And if you expand that out, you might want to pause and check. You expand that out, you get exactly the same as the line above. And then uses a difference of two squares approach, because what we've got here, it's hard to see, but what we've actually got is a perfect square. This whole thing here is a perfect square. We can write it as x squared minus y squared plus z squared, all squared. And then this last term here is actually a perfect square as well. So we've got minus 2yz all squared, and now it's a difference of two squares, which we can factorize. So follow that other solution to the problem if you're interested. However, I personally wouldn't have spotted that. The fact it's a perfect square and then a difference of squares, I wouldn't have spotted that. And we're given a hint in this question, right? We're given that we've got one of the factors. So how can we connect that to the final expression that we want to factorize? So what we do, and I'm not going to prove it, I'll leave that up to you to prove it. We've already shown that x equals y minus z is a solution, which led to x minus y plus z being a factor. If we look at the expression that we're trying to factorize, it's all even powered. And when you have a polynomial that is even powered, the minus will be a solution as well. For example, x squared, actually no, x squared is a bad example of it. We'll go, no, okay, x squared equals 9 has x equals plus or minus 3. If I had x to the 4 plus 5x squared plus 6 equals 0, that's another polynomial that's just got even powers. I could factor this as x squared plus 2 and x squared plus 3, and it has 4 solutions. They're all imaginary, but the solutions are pluses and minuses of one another. So that's the first thing to recognise in the expression that we're factorising. All of the powers are even, and so when we come down to here, we can straight away think of another one. X equals minus y minus z is a solution, and that will mean that x plus y minus z is a factor. Now, this is one where you'd need to prove this next result or come up with some argument as to why, but x equals y plus z is actually also a solution, and you can substitute it in like we did with the previous one and show that everything cancels. Therefore, x minus y minus z is a factor. And lastly, because of the even thing again, x equals minus y plus z is a solution. X plus y minus z is a factor. And we've got our 4 factors that we need, because if we multiply all those things together, we're going to get an x to the 4, we're going to get a y to the 4, we're going to get a z to the 4, and hold up, that needs to be a plus. We will get a z to the 4 now, and we'll also get all the other terms that we need, and other things that we don't need will cancel. So the factorisation is those 4 brackets multiplied together, and to save my time, I'm not going to write them all out. So interesting how a hint in the question can actually lead to the rest of the answer if you just take a little bit more time to stare at the expression. And I admitted, I personally didn't do that when I first attempted this. I went into brute force and tried to find this factor, and I just got absolutely lost in algebra. And often skull questions are tricky because they've got a twist in them. And I'm thinking of 2021, the last question I think was a simultaneous equation, and it wasn't designed to be one that took 2 or 3 pages to solve, but if you didn't notice the trick in like line 1 or line 2, you would go through 2 pages not getting anywhere. You need to reflect on that and maybe try a different approach.